Assalamualaikum warahmatullahi wabarakatuh to our lecturer, Mr. Nur Faizal Farid Muhammad Nur and fellow classmates. We are from team name 404 area in RCS 2406C group. Today, we would like to present our data mining project titled Productivity Prediction of Government Employees. So first of all, the project consists of 4 members. The leader of this group was named Muhammad Haikal bin Muhammad Jahan, followed by a group member named Muhammad Islah Hakimi bin Muhammad Idris, Muhammad Naufal Anik bin Khairul Amali, and finally, my name is Nurul Atika binti Syari. Alright, since I am the first presenter, I will begin by quickly describing the project's introduction before moving on to my part on the data cleaning process. To begin, the dataset that we chose for our group project is titled Productivity Prediction of Government Employees, which retrieved from the UCI Machine Learning Data Repository. It consists of combined nominal and numeric attributes, which have 15 attributes and 1,197 instances, along with some missing values. In short, the purpose of this dataset is to enable the government industry to track, analyze and predict the productivity employees' performance to make sure the integrity of the government products meets customer needs. Alright, after we study the dataset, we found that the dataset has 10 numeric attributes and 5 nominal attributes. Among the numeric attributes are targeted productivity. This attribute set by the authority for each team for each day. SMV stand for standard minute value. It is the allocated time for a task. WIP, work in progress, includes the number of unfinished items for products. Overtime represents the amount of overtime by each team in minutes. Incentive represents the amount of financial incentive. Idle time, the amount of time when the production was interrupted due to several reasons. Idlement represents the number of workers who were idle due to production interruption. Number of style change represent number of changes in the style of a particular product. Number of workers represent the number of workers in each team. And the last one is actual productivity. This actual percentage of productivity that was delivered by the workers, it ranged from 0 to 1. So for nominal attributes, there are date, quarter, department, day, and team. Represent the team number with the instance. So let's move on to the data understanding within cleaning process. After we analyze the data, there is one attribute that is categorical, but WECA detects it as numerical data. So in order to address this problem, the numeric to nominal filter was used since the attribute is intended to be an associated team number. As we can see here, these two figures illustrate the results after the filter has been applied. So the instance for the team attributes should be a distinct value from 1 to 12. Alright, next, the table that was stated here is a list of numeric attributes details which specified by mean, max, mean and standard deviation. It seems there are a total of 10 numerical attributes to be considered. And this one table contains a list of nominal attributes details with their associated values and counts. Logically, the count for each attribute is the same because there are indeed 1,197 instances. Okay, to proceed, in this part, we would like to identify the attributes with missing values. The missing values that have been identified are listed in the WIP attribute. To solve this issue, we can clean it by replacing all the missing values with apply replace missing values filter. As a result, we can see the filter handle the missing values effectively. Okay, for the last part, we would like to investigate the method for detecting outliers. So we apply filter interquartile range, which used to detect outlier values. And this filter can set the attribute index at default first last. It means it will apply the filter on all attributes, and the result was two new attributes called outliers and extreme value are added. So next, we should remove the outlier using filter remove with values. For this case, the attribute index are set at 16, which it means it will apply filter on attribute with index number 16. Then we set nominal indices at last, since yes equal to outliers. As seen in the result, we found that there are 57 instances that are outliers, which is compared to the rest of 1140 instances that are not outliers. Thus, the filter remove with values was applied. The outliers value turned to 0. Okay, so we use the same method and step as apply this filter to remove the extreme value attribute. As a result, the yes value for outlier and extreme value has been removed from all attributes and instance. Alright, that's all from me. I will pass to the next presenter to move on to the next slide.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Naufal Anik bin Khairul Amali, and I will be presenting on data preparation transformation for this group. So first, I will be explaining on discretization. The first one is WIP, which is work in progress. The other one is actual productivity, as you can see here. So the first one, work in progress, we have listing for 402, while actual productivity has listing of 706. It is a numeric type, it is a numeric type, and unique 324 for work in progress and 580 for actual productivity. So as we can see here, the minimum value is 300. The minimum is 313, maximum 1772, and so on. And for actual productivity, the minimum is 0.234, maximum is 1.12, and so on. So, filter discretize is used to utilize discretization for both attributes. So, for work in progress, the bin range precision is 2 and the bins is 3. And for actual productivity, bin range precision is 2 and the bins is also 3. Now, this is the before and after discretization for both work in progress and also actual productivity. We can see that the before discretization is the same for work in progress and actual productivity, just like before. It hasn't changed it. And for after, it has changed, as you can see here. The distinct before for work in progress was 402, and now it is 3. For unique, it was 324 and now it's 0. The type also changes from numeric to nominal. Now actual productivity also changes from before to after. As you can see here, distinct was 706 and now it's 2. The type was numeric and now it is nominal. The unique was 580 and now it's 0. We can also see in the table that it is different now. The label is kind of messed up at this current moment. So after discretization, I'll be explaining the progress afterwards. So discretization, we have made a renaming label. So we use the filter rename nominal values is used to change the label. So for WIP, which is work in progress, we use the rename nominal values, which is used to change the label. For bin 1, we use a low cost production. For bin 2, we use medium cost production. And bin 3, we have high cost production. Now it's for actual productivity. We also use rename nominal values. But for bin 1, we put least productive, and bin 2, we put most productive. So now we will be looking at before and after renaming label for both work in progress and also actual productivity. So at the left side, we have the before, and the right side, we have the after. So first, we will be looking at the before first. As you can see, after the discretization process, we can see that the label is messed up a little bit. So we need to change that. So we use renaming label. So as you can see from work in progress before and after, the label has been changed from bin 1, as I said earlier, which is low cost production. Bin 2 was medium cost production, and bin 3 high cost production. So we renamed the label from this random number into a proper name. Same goes for actual productivity. This is the random number and letters. So we use renaming label to change it from bin 1, least productive, and bin 2, which is most productive.
Okay, thank you so much, Naufal, for that explanation for data preparation process. So now we will proceed with model development and evaluation using the J48 classifier. Okay, so now the first process will involve cross-validation, and the first one we will use k equals to 10. So the result after the cross-validation has been applied is 81.1417 data accuracy. For cross-validation k equals to 20, the correctly classified instances or data accuracy become 80.9378%. Okay, the second process involves percentage split. So the dataset will be divided into two partitions, which is testing set and training set. So this will show the performance of the dataset. So the results for 70 to 30 partition result to 72.1088%. For percentage split 80 to 20, the result is 76.5306%. So this is the three visuals generated in Weka. So as you can see, the leaf node is the work in progress attribute. It will divide between the range of medium, low, and high cost of production, and the root nodes is the department attribute.
Now we're going to talk about data preparation reduction. We're going to talk about a ranking attribute where we are going to choose the attribute elevator in the selected attribute tab to use the ranking to rank the attribute related to class attribute. And as you can see, based on the result, the most related will be on the top and will be ranked, while non-related attribute will be on the bottom where the rank will be nothing but 0. Next, we're going to remove attribute. The attribute can be removed in the appearing process tab by checking the box. Based on the result from the last slide, there is 7 attributes that we're going to remove because it has 0 attribute in rankings, meaning it has 0 connection with the class. And now, as you can see, they are here is the result before and after. Before the attribute is there in the ranking, but while we remove it, there will be nothing but the most connected with the class. I'm going to pass it to Haikal.
Okay, so after the data reduction process has been implemented, we are going to run again the model development evaluation using the J48 classifier. So for cross-validation falls k equals to 10, the results of data accuracy is 83.4862%, which shows an increased percentage. For cross-validation k equals to 20, the results of data accuracy is 84.1998%, which also shows an increase. And for the percentage split process, for partition 70 to 30, the results of data accuracy become 72.1088, which remains constant. And for percentage split 80 to 20 partition, resulted to 86.7347% in data accuracy, which it also shows an increase. And this is the generated 3 visuals after the data reduction. And for some reason, the number of leaves the number of leaves and the size of the tree increased, but still the department attribute become the root nodes, and the medium and the work in progress attribute become the leaf nodes. And this is the bar chart to compare the model development evaluation results before and after data reduction. So this shows that for K10 shows an increase 81 to 83%, and for K20 from 80% to 84%. For 70 to 30 partition of percentage split process shows a constant percentage, constant result. And for the 80 to 20 data partition shows an increase from 76% to 86%. Okay, that is all from us. Thank you.